correlation example 3. In this example, we're asked to calculate a correlation coefficient for two sets of data. We're looking at the dominant hand span, that is whether you're right or left-handed, that will be your dominant hand, and your dominant foot length. So hand span and foot length is what we're looking for a connection between, and we've got a set of data here. The first thing that we have to do is work out all those summary statistics, because we're going to need those in our calculations. So what I'm going to do is I'm going to write them down here, and I want you to pause the video and check that you can work all of these out. Sometimes they're given for you in the question. Sometimes you have to work them out yourself. So it's important that you can do this, but it is quite time consuming. So have a go, pause the video, and see if you get these. So sum of y squared, I got 681508. I'll write the others up here. Sum of xy, I got 590417. And n is 10 in this example. So check you can get those. To work out the correlation coefficient, we need to work out SXX, which is sum of x squared minus the sum of x all squared over n. Substituting in the values, 513773 minus 2259 squared divided by 10. And if you work that out, 3464.9. If you get really long decimals, it's important to save them in the memory of your calculator so that they're exact. If you don't know how to do that, ask your maths teacher and they'll show you how to store numbers in the memory, because it saves you typing in all those decimals lots of times. XYY, again, if we substitute in the values in the correct places, and for this one, if you do that calculation, you should get 298. Make sure you keep pausing the video and having a go at these yourself. So we have sigma x, sigma y over n. Again, substituting the values, we have 590417 minus 2259 multiplied by 2610 all over 10. And when I did that, that worked out to be 818. So you get quite a few marks for doing that in the exam. We'll do an exam question later. And now we can actually substitute them into our formula for R, which is the correlation coefficient. So we've got SXY divided by square root SXX SYY. So if we work that out, on the top we've got 818. On the denominator, we have 3464.9 multiplied by 298. And if we work that out carefully on our calculator, round it to 3SF, that's what we get. Now, from looking through the notes on the previous page, you'll see that this is fairly close to a value of 1. The question in the notes says, calculate the value of the product moment correlation coefficient, describe and interpret this coefficient. So the description is the mathsy words. So the description is, there is a strong, I'd call 0.8 strong, it's very near to 1, strong positive correlation. That's maths words. The interpretation means, well, X was hand span, so the larger the hand span, Y was foot length. So the larger the hand span, the larger the foot length. Or you might say, as hand span increases, foot length increases. So that's a general pattern, and I would say that's probably true of most humans. The bigger your hands, the bigger your feet. A fairly strong link.